So in this case, the balanced equation for the reaction of sodium chloride with sulfuric acid is as follows. We have 2 moles of sodium chloride reacting with 1 mole of sulfuric acid in order to produce 1 mole of sodium sulfate and 2 moles of hydrochloric acid. During a reaction, 1.5 grams of an impure sample of sodium chloride reacts with 100 cubic centimeters of sulfuric acid with a concentration of 0.1 mole per cubic decimeter at room temperature. Now, the first question is asking us to define the term concentration. Well, I honestly trust you to do that one. Now, moving on to the next one, they say to us, please calculate the number of moles of sulfuric acid that were used in this reaction, all right? And of course, we can actually do that because we are given the concentration as well as the volume. So it's very easy to do so. I think we can quickly do that. So let's quickly do that. So it's easy, 3 marks. Well, here we are just going to state the definition of concentration. So we say, well, concentration is defined as the number of moles of a solute per liter of a solution. So this is what we say. But now it is given to us that the concentration is 0.1 and we are looking for the number of moles. But the volume is also going to be 0.1 cubic decimeters. Remember that when you move from centimeter cubed to decimeter cubed, you divide by 1,000. So that's how we obtained the 0.1 there. And then, of course, in order for us to make the number of moles the subject, we just need to cross multiply. So when you go to your calculator and say 0.1 times itself, well, you find that 0.01 moles of sulfuric acid were actually used in this reaction. All right? Okay, fine. So now we can look at the next question. Well, so next they say to us, on completion of the reaction, it is found that 460 cubic centimeters of hydrochloric acid gas has been formed. Please calculate the percentage purity of the sodium chloride and use 24.45 cubic decimeters as the molar gas volume at room temperature. And remember what I told you, the molar gas volume changes depending on the mood of the examiner. So this is what today's examiner woke up. I don't know woke up doing what, but this is what he decided to say. So now here we need to decide, right? Because in order for us to find the mass of sodium chloride, that's if we know the number of moles of sodium chloride, okay? But the question is, are we going to use the number of moles of sulfuric acid, or are we supposed to use the number of moles of this formed hydrochloric acid gas? Well, which one is it? Which one are we supposed to use? Well, we actually need to prioritize this hydrochloric acid gas which has been formed. So that's what we are going to use. We use hydrochloric acid so that we can find the moles of sodium chloride. And then we can find the mass of sodium chloride. Awesome. So every time they say that to you, you always prioritize a gas that has been formed. So it means this 0.01 actually becomes obsolete. Okay. So here we are just going to quickly find the number of moles of the hydrochloric acid gas. And here we use the formula of volume divided by the molar gas volume. Our volume is given to us in cubic centimeters. So we need to convert it to cubic decimeters. And of course, we understand that we need to divide by 1,000. And so we find that our volume will just be 0.46. And we divide this by the molar gas volume, which is just going to be 24.45 cubic decimeters. And let's see how much we get when we quickly press this into our very nice calculators. Well, we find that the moles will simply be 0.01, let's say 88 moles. Okay, fine. So now that we know the number of moles of the formed hydrochloric acid, then what are we going to say? Well, we are just going to relate sodium chloride with hydrochloric acid. And here we see that they actually relate in a 1:1 ratio, which means the number of moles of sodium chloride are exactly equal to the number of moles of hydrochloric acid. Of course, these number of moles are just 0.0188 moles, right? But I think you agree with me, or you are rather surprised why I'm choosing to use 1:1. Well, it's because in the original question, they said the mole ratio is 2:2. But of course, 2:2 is the same as 1:1. So there's no difference really. But of course, you could have chosen to say 2:2. You'll still get the very same answer in any case. Right. So now we know the moles for sodium. Now we just need to find the mass. And of course, we go to our famous formula. And this is what we say when we get to our very nice and beautiful formula. So, well, what is the molar mass for this sodium chloride? Well, for sodium, it's 23. And for chlorine, it's 35.5. So if we say 23 plus 35.5, well, you simply get 58.5. And so in order for you to find the mass, you just cross multiply. So you are simply going to find that your mass is 1.0998, which of course, if you take to 2 decimal places, you find that it's going to be 1.1 grams. Okay, fine. So now we know the mass of sodium chloride in this impure sample, then it's now easy to find the percentage purity. So you say, well, it's the mass of this thing divided by the mass of the sample, and then you times this one by 100. But I think it's actually similar to the one we did before. So you find that, well, it's just going to be 73.33%. And you should be happy.